this is the recording from vectors 1. Okay, so we start off with collinearity. 3 points A, B, C will be collinear if they satisfy two conditions. The first condition is that two vectors are parallel. So let's say AB is parallel to AC. And we can prove this by proving that AB is a scalar multiple of AC, and then we find K. And then the second condition would be that there is a common point. And in this case, we can say that common point is B. Therefore, we can prove that ABC are collinear. Okay, let's branch off from this parallel thing. Okay, so if K is more than 0, in general, we can say that AB and AC are in the same direction. However, if K is negative, then we can conclude that AB and AC are in the opposite direction. So it will look like, okay, AB is like this, and then AC will also be in the same direction. But AB, if it's like this, then AC would be in the opposite direction. So here would be A, B, C. Okay, this is a very popular question that is about collinearity. So the question tells you that X is a point of intersection of AB and CD. Then they want you to find vector OX. So the standard procedure for this kind of questions is to firstly find the vectors that intersect at X. So they tell you the vectors that intersect are vectors AB and vectors CD. So you need to find vectors AB and vectors CD, and can re-express, you can just find these first. So it would be B minus A, CD would be 2 over 5B minus 3 over A. So this is actually using your subtraction vector rule. It's like AB equals to OB minus OA to get this. Okay. And then after you get these two vectors, you know that they can be re-expressed in terms of OX because they are actually like collinear. So if for example you take points A, X and B, AX, B are collinear and they can be separated by X. So you can say that AX is parallel to AB. So do AX is parallel to AB, so I can say AX equals to K times of AB, where K is a real value. And then you can do OX minus OA equals to K times of AB. And then you like get an expression for OX in terms of K. So you will get 1 minus KA plus KB. And then from using CD, you do the same thing. So like CXD is collinear. So CX and CD are parallel. So I'll do CX equals to lambda CD, where lambda is a real value. And then you do the same, and you will get OX equals to 3 over 2 minus 3 over 2 lambda A plus 2 over 5 lambda B. Okay, so now you have two equations of OX, but they are in terms of K and lambda, so you need to use simultaneous equations, which is the third step. So I'll equate them together. 1 minus KA plus KB equals to 3 over 2 minus 3 over 2 lambda A plus 2 over 5 lambda B. So now you can go on to say that you can compare the coefficients. Let's say 1 minus K equals to 3 over 2 minus 3 over 2 lambda, and K equals to 2 over 5. This method to work for comparing the coefficients to hold true, A must not be parallel to B. So this is because like, okay, let's move all the A terms to the left hand side. 1 minus k if A and B are parallel, then I can say A equals to KB. And then, so, this would be like a constant, and then you cannot say that this is equals to 0. Because I need, for this to be true, I need this to be 0. So like 1 minus k minus 3 over 2 plus 3 over 2 lambda equals to 0. Then I get 1 minus k equals to 3 over 2 minus 3 over 2 lambda. But if A and B are parallel, then I cannot make this to be 0. So it wouldn't make sense. And so I think you must write this reasoning down as part of your working. And the question will specify that A and B are in parallel. So this is just an important note to take. So since because of this, you can compare and then you will get this. Secondly, we have the dot product. So this is also called the scalar product because it gives a scalar. So the formula is A dot B equals to mod A mod B cosine theta. The algebraic expansion of A dot B is, let's say A equals to 1, 2, and B is 3, 4. Then the algebraic expansion would be 1 times 3 plus 2 times 4. So it will be 3 plus 8, which is 11. Okay, so how it works is that you multiply horizontally as the product, then you add it. Okay. If the question requires you to find theta and they specify that theta is an acute angle, and let's say you get cosine theta equals to negative 2 over 3, and you will get like an obtuse angle of, I think it's 131. So because the question says theta must be acute, then you must say that theta equals to 180, you know, okay, this angle is obtuse, and then because you know the ASTC is here, theta is, alpha is 131, therefore theta is 180 minus 131, which is like 48 degrees. Yeah. Okay, I forgot to mention that the basic thing is that for any vector AB, you can find it by using OB minus OA. So it's always like the one after first, and then followed by the letter that's before. Okay. Oh, I also forgot about the ratio theorem. Okay, so okay, 0.5. The ratio theorem shows that for any triangle, let's call this 0 O origin, A, B, C, and then if we know OA, which is A, and OC, which is C, then we can find the middle vector OB, which is B. And if we know the ratio between AB and BC, then we can work out B in terms of A and C. Let's say AB to BC is lambda is to mu. Then by ratio theorem, you can say vector B equals to A mu plus c lambda. So it's always like opposite of the vector. Okay, then your denominator will be lambda plus mu. Okay, let's move on to the cross product, which shows us a vector. Okay, so the formula is n vector equals to a cross b, which can be rewritten as mod a mod b sine theta. Okay, so the dot product has cosine theta, but cross product has sine theta. Oh wait, because a cross b gives you a vector n, and this is technically a scalar, therefore we need to add the unit vector of n to make this a vector. Let's move on to the algebraic expansion of a cross b. If a is 1 2 3 and b is like 3 4 5, a cross b, which is 1 2 3 cross 3 4 5, it will be like crisscrossing method. So if we look at the first row, we look at the one below the first row, so 2 times 5 minus 3 times 4. So that will be the first vector component of our resultant vector. And then our second component of our vector would be, we look at the second row, then we look at the one below it. So 3 times 3 minus 1 times 5. So it's like a shoelace crisscrossing method, and you always go from left to right. Oops. Okay, and then our third row is here, right? So we look from the one supposedly below the third row, which would be going back to the first row. Okay, so 1 times 4 minus 2 times 3, and then you can calculate, and then you will get some vector, and this vector would be n, which is a cross b. Going back to the formula, this formula. So if the question tells us that some random vector a cross b equals to a zero vector, then we can conclude that there are 3 scenarios. The first scenario would be that a is a zero vector, or b is a zero vector, or a is parallel to b. Because from the formula you get sine theta, right? So for sine theta to be equals to 0, theta will be 0, therefore they should be parallel. So technically you can draw these 3 conclusions, but usually they will specify a and b to be non-zero vectors, but you have to be careful if they don't specify these conditions. Okay, also if they ask us for the magnitude of the cross product, it would be mod a mod b sine theta, and then because mod of your unit vector is 1, you can just ignore this. So the magnitude of the cross product would be this: mod a mod b mod sine theta. Okay, so what are some applications of using cross product? So the cross product gives you a vector, but it also gives you an area. So the area of a triangle let's say triangle ABC. Oops. ABC. If you know vectors AB and vectors AC, and you know they are joined together by angle theta, then you can know that area of triangle ABC is half of the magnitude of the cross product of AB cross AC. And you also know area of parallelogram. Let me draw a parallelogram, then ABCD. If you know vectors AB and vectors let's say AD, then you'll know area. So area would be the magnitude of AB cross AD. Okay, let's move on to projection vectors. Okay, let's draw some vectors. Label this A, B, origin. Okay, then I draw a dotted line down, and this will be N. So if I know OA to be A and OB to be B, I can find vector ON. We will say ON is the projection vector of OA onto OB. And then you can use the formula ON equals to OA dot unit vector of OB times unit vector of OB. How this works is that, okay, it actually depends on like the order that your vector comes in. So because your OA is first, right, so you can remember that OA is first in front of the formula, and then OB would be your unit vector, and then OA dot unit vector of OB, as we discussed earlier, the dot product means that this is a scalar product. So because this is your vector, you need your unit vector here. It's the same. Okay. And then if you want the magnitude of your projection vector, it would be just mod of this thing. So it will be mod OA dot unit vector OB. And then like just now, technically you have mod. Oops, what's this? Technically you have the magnitude of your unit vector here too, but because the unit vector is 1, so you can cancel it, ignore it. So your magnitude of your projection vector would be this. You can see the similarity.
Let's end off with the vector components. So we say that ON is the projection vector of OA onto OB because if we look at vector A, ON is the horizontal component of A onto like this OB vector. So the vector component of OA that is perpendicular to OB would be the vertical component of vector A. So it's like resolving your vector A into horizontal and vertical components. Okay, so your vector component of OA that's perpendicular to OB would be NA. And to find NA, you can form an equation. So vector A is equals to vector ON plus vector NA. Then NA would be vector A minus vector ON. So you have to like find the projection vector, which is this, and then like to find your vector component of whatever. So you're moving on. The magnitude of your vector component would be, okay, earlier we said magnitude of your projection vector is whatever dot unit of whatever, right? Okay, in this case, the order of your vectors is also important. So OA comes first, and then we will say that magnitude of NA is OA cross unit vector of OB. Do you see like the similarity? Projection vector, I will use a dot, and then vector component I will use a cross. And the order OA and then OB here also applies OA OB, OA OB. I must remember that OB is a unit vector. Okay, OA cross unit vector of OB is actually a vector, but because we have like the mod here, you mod the vector which will then give you the magnitude. Okay,
this is where it gets interesting. Okay, so let's say the question asks you, what is the geometrical interpretation of like geometrical interpretation of n goes to mod A cross B. So there are actually two possible interpretations depending on the context of the question. If the question doesn't specify that B is a unit vector, so it just says this random thing, then you can say that it is the ask what's the geometrical interpretation of this. Okay, so you can say it is the area of parallelogram whatever, okay. But if the question specifies that B or A is a unit vector, so they say it is mod A cross mod B. And you have to be very careful because like yes, it's a unit vector, so this doesn't really apply because you don't have B doesn't have to be a unit vector for the interpretation of the area to work. So there must be a reason why they specified B to be a unit vector. Okay, so if you look at this, you stare at this and you think long enough, then you think this looks very familiar. So you have actually seen it here. This is actually the magnitude of the vector component that is vector component of A that's perpendicular to P.